Hey guys, this is for the AP Statistics 2020. I can see them asking a problem like this. I made this problem up. It has 5 parts, and I think it's really going to help you guys. So good luck on the exam. A book company wanted to determine if a new book that was designed could help increase student scores on a standardized test. 100 students volunteered to be part of a program to help increase their scores on a standardized test. 50 students were randomly placed into the experimental group where they were given the book to help them study, along with a tutor twice a week specializing in the exam. Okay, so the tutor specialized in the exam. Okay, while the remaining 50 students were placed in the control group and were given just the tutor twice a week. The students in the experimental group were told to study 1 hour each day for 2 weeks. The students in the control group were told they could just use the tutor twice a week for 2 weeks. Assume each student did study each day for 2 weeks. In other words, assuming everybody followed instructions. Let mu e denote the average score on the standardized tests for those participants in the experimental group, and let mu c denote the average score of the standardized test for those participants in the control group. So here I wrote a 90% two-sample t-interval for mu e minus mu c. The difference in the population mean averages points, average points rounded was 20 to 40. I just made these numbers really nice so we could just get the understanding of it, okay? So 20 to 40. I said the conditions are met. What are those conditions? Explain why they are met. Okay, so the distribution is approximately normal because in both groups we have a sample of 50 individuals, and since 50 is greater than 30, by the central limit theorem, we can assume that the distribution is approximately normal. The stem of the problem states that volunteers were randomly assigned to one of two groups. So even though they were volunteers, they were randomly assigned. So I wrote here the conditions are met because random sample or random assignment and normal or approximately normal were both met, okay? So that's why the conditions were met. Both groups had over 30 and they were randomly assigned. Great. There's nothing about a 10%, it's not a proportion, okay? Then I wrote here, based on the confidence interval only, what conclusion can be made? Well, the confidence interval was 20 to 40. Okay, so those numbers are both positive. Okay, so I wrote, since 0 is not in the confidence interval, we can conclude that there is a difference in the average. Since it contains only positive values, mu e is greater than mu c at alpha equals 0.04. So roughly, the people who used the book are going to score 20 to 40 points higher than those who didn't. But because 0 is not in the interval, or because they're positive values, it's greater at alpha equals 0.05. I'm going to talk about this in a minute, okay? Remember the question says to help increase. Increase means greater than, it means one-sided, okay? Also, remind yourself that this is a 90%. So I'll tie everything together soon, okay? Now, this says, what is the point estimate and the margin of error? Well, a point estimate is either x bar or p hat, okay? So in this case, we're talking about averages. So the point estimate is going to be, okay, so every confidence interval can be written as this, point estimate plus or minus the margin of error. To find the point estimate, that's just going to be the average of the interval. 20 plus 40 divided by 2. That's 30. After that, I just have to see what my distance is from either one of these. So from 30 to 40 is 10, or from 20 to 30 is 10, so the margin of error is 10. Isn't it true that we can write this as 30 plus or minus 10? So this is the work. You can pause the video, take down notes if you want to, but that's how we find the point estimate. The point estimate is either p hat or x bar, and it's just the average of the interval, okay? Now, the final question, well, I added the last question, letter E. But letter D, the conclusion that was made in part B was made at alpha equals 0.05. Explain why it was at alpha equals 0.05 and not 0.10. That's a great question. I'm so glad I made it up. Well, this is a 90% confidence interval, okay? If you take a look at 90% confidence interval, you have 5% left on each side, to make the 100% for the normal curve. If you are going to do a greater than, that means you're only looking at one side, and that's why it's 0.05. If you were looking at less than, it would also be 0.05. So if it's one-sided, less than or greater than, you just pick one of these. Now, had the question said, is there a difference between the two? Then you would have to conclude, yes, there is a difference, but at the alpha equals 0.10, because when it's two-sided, you got to take both of these p-values, okay? Or both of these alphas, rather. So that's why it was, so you can draw this picture and just say, since they wanted or asked about increasing, it's a one-sided, it is one-sided, and you can just say based on my diagram, we see that alpha equals 0.05 is the right side. Something along those lines, okay? And I just added the letter E. I said, why is this an experiment and not an observational study? Well, you can always do this for one of two reasons, okay? It's an experiment because a treatment was imposed, and you should say a book was given. That's your treatment. Or you can just say random assignments of groups. Okay, so that is what makes an experiment. So some treatment has to be imposed, or there has to be some sort of randomization. So this is a nice problem, I thought. I thought that this would be one of the more challenging problems, just in case they gave you a hard question. But I hope it helped. I'm going to make a few more similar problems, part A through E, and I hope you subscribe to my channel and you like the video and you comment and all that good stuff. I'm a mathematician. I don't write this stuff over here. I made this stuff up, so I apologize about the English portion of it. I know that I don't really like to make up these problems. All right. Anyway, enjoy.